So, the next question that we will try to answer is when the toString method gets called from inside the method M, which implementation of the toString method along this inheritance chain gets executed. That means we have seen that we pass different types of object when the type object is needed because of polymorphism. Now the question is, which toString method from this several types of classes gets executed? So in order to answer this question, let's look at a few definitions first. So in this case, the polymorphism enables us to write this line of code. That means object O equal new student. When we write this line, first we are actually declaring a variable of type object. That means in the memory, O will contain the location of the actual object. But we are creating the object of student class by this new student. So we can see that we need the type object. When the type object, a supertype, is needed, instead of the supertype, we can actually use any of its subtype like new student. And we assign the address of new student into this variable O. So here object is called O's declared type and student is O's actual type. So which toString method is invoked by O is determined by O's actual type. That means this is known as dynamic binding. So dynamic binding works as follows. Let's say we have an object O which is an instance of classes C1, C2 up to Cn-1 and Cn, where C1 is a subclass of C2, C2 is a subclass of C3, and finally Cn-1 is a subclass of Cn. So if we draw the inheritance diagram, it looks like this. That means Cn is the superclass, its subclass is Cn-1, its subclass will be Cn-2, and like this C2 and its subclass C1. So in Java we know that this superclass is our object class of Java. So this Cn class or the object class is the most general class and this Cn is the most specific class. So so if O invokes a method P, the JVM searches the implementation for this method first in C1. If it does not get the implementation in C1, then it starts searching in its immediate superclass C2. If it does not get the implementation in class C2, it goes to the immediate superclass C3. So along this chain, whenever it finds the first implementation anywhere, it executes it. So once an implementation is found, the search stops and the first found implementation is invoked. So this searching and execution by JVM is known as dynamic binding. So initially, we have seen method matching when we had method overloading. Now we have seen dynamic binding when we apply method overriding. So what's the difference? So matching a method signature with the name, parameter list, number of parameters and so on, and binding a method implementation, that means where method signature is same, return type is same, only the implementation along inheritance chain or difference, these are two different issues. So the compiler finds a matching method according to parameter type, number of parameters, and order of the parameters at compilation time. Whereas a method may be implemented in several subclasses. So the Java virtual machine dynamically binds the implementation of the method at runtime. So this polymorphism and dynamic binding together enables us to have generic programming. So polymorphism allows methods to be used generically for a wide range of object arguments. This is known as generic programming. For example, if it did not have polymorphism, then we would have to write the M method several times, every time for different parameter type. That means once for the parameter type object, then we needed to overload method M with parameter type person. Then we needed to write another method M with parameter type student. Then again another method M with parameter type graduate student. But we can generalize the method M by using the most general superclass as its parameter type, and this is generic programming. So if a method's parameter type is a superclass, for example object, you may pass an object to this method of any of the parameter subclasses, for example student or string. So when an object, for example a student object or a string object, is used in the method, the particular implementation of the method of the object that is invoked is determined dynamically according to the actual type of that object.